this video, I'll be going over linear inequalities and absolute value inequalities. So this is an example of a linear inequality. It's an inequality because we have an inequality symbol right here, and all the terms are linear. X to the first is the highest exponent. So how we solve a linear inequality, we want to just isolate x. So it's kind of like we're solving a regular equation for x. So I'll add 2x to both sides, and then I'll add 5 to both sides, and then divide by 3. We get x is less than 8/3, or 8/3 is greater than x. So to write the solution, we want to use interval notation, but before I do that, I'm just going to graph this on a number line to get an idea, to get a visual representation of what's happening here. So what this is saying is 8/3 is greater than all the x values, or we could also flip everything around and write it like this: x is less than 8/3. So what this means is 8/3 is the cutoff, and all the x values are less than 8/3. And what we do when we have a greater than or less than symbol, we use either an open circle or parentheses on the number line. If it's greater than or equal to or less than or equal to, we use a closed circle or square brackets. So on the number line, we could do a parenthesis like this. We could also have used the open circle. I like to use the parenthesis because that transfers very nicely into interval notation. So our solution is negative infinity to 8/3. And what this means is x could be any value inside of here. Okay, so any value in the shaded area or any value in this interval, if we plug that into the inequality, it's going to be true. Let's do one more of these. Here we're going to distribute on the left side and the right side. We get this. Okay, I'll collect all the y terms on the left side. We get negative 4y minus 3 less than or equal to negative 8. Add 3 to both sides. I get negative 5, and then divide by negative 4. So we need to be careful. This is the one difference when we're solving an inequality versus an equation. When dividing or multiplying by a negative, what we do is we reverse the inequality. So instead of this being y is, or negative 4y is less than or equal to, we're going to change it to greater than or equal to, and then negative 5 divided by negative 4 is positive 5/4. Okay, so expressing this on a number line, 5/4, we're greater than or equal to that, so greater than or equal to, I can use a square bracket. So in interval notation, the solution is going to be 5/4 to infinity. So next, let's look at absolute value inequalities. And absolute value inequalities are really just taking linear inequalities and adding one little tweak to them. So suppose we have 2x plus 3 in an absolute value less than 7. So how we go about doing this is, well, because this is an absolute value expression, we still branch this up into two inequalities. And what we do here is we write the first branch the same. We just remove the absolute value symbol. And then on the second branch, we also remove the absolute value symbol, but we reverse the inequality and we take the opposite sign of whatever value is on the right-hand side there. So we reverse this and we take the opposite of this. And then from there, we just simply solve each branch as we would a regular linear inequality. So we get x is less than 2. x is greater than -5. All right, so it's helpful to graph this solution on a number line to help us visualize what's happening. What it's saying is x could be less than 2, or it could be greater than -5. So what this means is the correct values are in between -5 and 2. And because we have greater than or less than symbols, we use parentheses. So to write the solution in interval notation, we'd say -5 to 2, and that's it. So the values that would make this inequality true are anything between -5 and +2. All right, and then let's look at one last inequality here. So this is an absolute value, so we're going to branch this into two inequalities. Remember, reverse the inequality symbol, take the opposite sign on the right-hand side, and then we just solve as we were before. So multiply both sides by 4 here, and then add 3. X is greater than or equal to 11. Add 4. Multiply by 4, we get -8. Add 3, we get -5. So on a number line, what this is saying is x could be greater than or equal to 11, or it could be less than or equal to -5. Okay, so we're going to get two parts to the interval. We're going to say -infinity to -5, square bracket, union, square bracket, 11 to infinity. And there you have it. Now, let's contrast this solution with the previous solution. So in this solution, the interval is only has one part. There's no union. So kind of a silly way to help us remember that is if we have a less than or equal to, how we can think about this is less than, and what this means is x is less than 2 and greater than -5. So when it's the and, that's when we have a single interval. This one is greater than or equal to, we can say greater. So here we're saying x is greater than or equal to -11 or less than or equal to -5. So when it's an or, the inequalities go apart from each other, and then when it's and, the inequalities are going towards each other.